Okay, back on this 8903 audio analyzer, and having pulled this board out, we can see how bad this capacitor is. It's loosey-goosey, and it's wobbling around. In fact, it did stop the whole thing working at one point because it was shorting out, stopping the oscillator working. So I guess I've got to get that out, but I did print the circuit diagram out, which is absolutely minute, but it's looking at it on a computer screen. I could see what I was up against, and that's your crystal, and that's the variable capacitor, which is 2.4 to 24 pF, and I think it would be highly unlikely that I can fix this one, because obviously the tension's gone on the back where it's riveted together or whatever it's done. But there is a good chance I'll have something similar to that. I don't think it's a high precision frequency anyway. It doesn't need to be for audio purposes, but as long as it's on 2 megahertz, that's the crystal frequency, within a few tens of hertz, it'll be fine, I'm sure. So the next job to do is to get this thing out, and I guess I can try using my Duratool solder sucker, which is fairly hopeless most of the time, but it would seem to be the best option, as this is a plated through board, and there are the 3 pins for the capacitor. I don't want to damage anything, so I'll have a go with the Duratool in a minute. Okay, let's see if we can get this capacitor out. So, where are the pins? Where are the pins? There they are. Fresh solder. That's what it needs. Fresh solder. Before I do that. Right. Didn't go very well. I've never been very impressed with this machine. Give it one more try, and then I'll go to plan B. No, I didn't do very well at all. Right. I'm going to have to try something else to get this out. Well, I actually got it out by heating it up and individually lifting each pin in turn, and that worked quite well. But the solder sucker did get most of the solder out, to be fair to it, and I haven't taken any of the plating off the holes, so that's always a bonus. Now, I have been looking at replacements, and I haven't got an airspace one, but I don't think it's critical. As I said, it doesn't need to be particularly high stability or whatever. So let's have a look at this. This one I found. Okay, it's not going to stick up like it should do, but let's look at the board. It's got to go ideally like that, but what I might do is, because I don't really care what this thing looks like, I don't need it to be perfect, I might just glue it. I might solder the two common pins to the board, because they'll stretch, then take a wire from that pin down to the connection down there. But anyway, let's look at this capacitor that I found. It's quite a high quality one, and they were quite expensive years ago. So it's got a minimum of 6 PF and a maximum of 50, and the old one was supposed to go up to 24, so it's not absolutely ideal. But I still get some get somewhere close to what I need by adjusting it, I'm sure. So that is my plan, is to solder that one in and make it stick up by gluing it to the board, probably with super glue. So I'll go ahead and do that. So I've actually been looking at the old Tremor capacitor, and it's more or less just fell apart in my hand. That's the bit that goes through there, and then there's a bit that goes on the back, if you can see that, and that was just extremely loose. I wonder if that's fixable. Let's come back on. It's very, very loose though. It's not stable. So, what do I do about that? I think what I could do, if I can get that off again, no, I can't get the pliers in there. If I could, what could I do? I could bend this to give it a bit more tension, but I think that bit that retains it is just too loose. Too loose. I wonder if I could actually solder the whole thing together. After all, it is ceramic, so it won't melt. But I think that's a bit too complex to do on camera. Now I can't solder it together because this bit needs to move. Can't solder the middle bit to the tag. If I could crush that slightly and push it on, maybe, we'll see. So, I've been fiddling around with this for ages, and I think I've fixed it. If you look now, it's fairly stiff when you turn it. Certainly won't be falling around and changing in capacitance. And the way I did that was that metal bush on the back, for want of a better word, I crushed it slightly so it was a tighter fit, but I wasn't going to rely on that only, so I soldered it on, and that was fairly easy because it's brass, hoping the solder wouldn't migrate down into that contact. So that would have been the end of my day then. But I put it on the LCR meter now. And zoom out a bit. I put it to minimum 6.7. It says 2.4 on the circuit diagram, but whatever. I'm not sure that it's that, and of course I'm touching the leads, which doesn't help. Touching the leads doesn't help on the capacitance meter. I turn it all the way around, maximum capacitance. I get 28, and it's supposed to be 24. Again, I'm increasing it by touching the leads. So I think that should work fairly well. And just in case you wondered, none of the vanes are shorting out. So that seems fairly good, a fairly good fix. It took about an hour to do that, all over one capacitor. But I do like to fix things, so that's good. So get it back in the board, and I'll see if I can do this frequency adjustment. So there it is, back in, and that adjusts very nicely. Nice sort of tension on that when I'm turning it, so there's no chance of it moving when it's knocked around or anything. So I just get it all put back together, and we'll get on with the test. Okay, this is the signal on test point 15, which is the 2 megahertz coming from that crystal, which has been inputted in. The crystal is connected to this microprocessor basically, and this is the clock signal that comes out. And what they want you to do is they want you to monitor this signal while externally triggering off a 10 megahertz time base, and so this waveform will drift around. Now I don't like that, and then you have to tweak it until you get a stable waveform off an external 10 megahertz reference as a trigger. But I don't like that idea. I think it's far better to use a frequency counter. That's a decent accuracy. It's a much better way of doing it, in my opinion. But first of all, I need to let this unit warm up. They do say wait for 15 minutes. That's what I'm going to do, and I'm going to put the cover back on. Okay, so it's been on about 15 minutes, and warmed up and it's fairly stable, and as you can see we're looking at an error of 15 Hertz, and I think it said in the manual plus or minus 15 Hertz is what they need you to set it to. So I should be able to get it closer than 15 by adjusting the capacitor, and that is very close enough, plus or minus 15 Hertz, and that's 0.1 Hertz out, 0.15 Hertz out. So I think that's all I need to do on that. As I said before, this crystal oscillator, it really only is used as a clock for all the microprocessors and for the counter on the front, frequency counter, you know, so it doesn't have any relevance to the or it may have indirect relevance to the actual signal that comes out of the unit, because this does not work as a frequency synthesizer for obvious reasons. A frequency synthesizer circuit would probably be more noisy than whatever they've got in this one, but they must do a comparison of some sort with that 2 megahertz clock signal. So that's about it for now, but I just want to go back and check those distortion figures again, because I made some fatal errors on that last video. In fact, I only discovered it once I'd put the video up and watched it, and I don't know what was going through my head that day, but you know, we all have bad days and make mistakes, so that's the way it goes. But that guy that said I should be getting 0.005% distortion, well, I was getting better than that. What am I getting in the moment? 0.0045, and he was saying 005, so that is better than it was, than what he said it should be. But those adjustments I did yesterday when I was getting over 98, over 90 dB, 93 dB, that seems to drop back down to 87 now for some reason. So I'm going to play with this a bit longer and leave it for a bit longer to warm up and try tweaking that again. Okay, well, I've been tweaking again and I've got it back to nearly as good as it was yesterday at 92.8. It almost gets to 93 at times in log mode, and if I go back to so that is nearly 3 dB better than what they specify as 90. But if I go back to percentage, I'm down to 0.002, which is a good deal better than the 0.005 that the guy on YouTube said I should be getting. So I think that is the end. Of course, there's many more things I could do with this, because it's an old instrument. I could go through the whole calibration routine, but I'm not going to, because for one reason, I haven't got some of the test equipment required. I haven't got a precision AC source for calibrating the level, AC level, which is now reading 3 volts, the AC voltmeter. So I can't do that calibration of that. There's probably other things I could do, but as I said, I think it's as good as it's going to get, and I'm quite happy that I've improved that overall reading now to whatever it was, 0.025, 0025. yeah, I'm more with it today, so hopefully I made amends to that crap video I put out yesterday. So thanks for watching, and bye for now.